Hello, this is Dr. Young, and I'm going to go over your week 4 presentation as soon as it comes up here. There we go. Sorry about that. Sometimes it's a little slow. So we are going to go over Chapter 4 this week. And this is the Framing for Learning chapter. And we're going to talk about some history here, some background. So we talked about a little bit about how Lean derived from the Toyota production system. And so basically, this production system was a response to 3 constraints in the 50s and 60s. There was intense competition with Nissan, Mazda, and Mitsubishi. And then self-funding. It went bankrupt in 1950. So this required them to use existing lines because they had limited funds. So they had to maximize their lines and make them as efficient as possible. And then there's so value analysis, value engineering with suppliers. That was basically during this process when they needed to make their lines more efficient. And they couldn't add any more. They had to ask for innovation from their suppliers. So they had to even extend that out to their suppliers of parts. How could they get the parts? It might have been different aspects of the part itself, the lead time, supply, shipping times, all those little things. They asked all their suppliers to also innovate as well. So it really extended beyond that line, that manufacturing system at Toyota. It went to their suppliers as well. They wanted to ask them how they could innovate, how they can make it, whether it's parts that fit better or lasted longer, or however that added value to their automobiles. They were asking for that too. So basically they wanted the suppliers to, and obviously it wasn't called Lean at this point. This was the point where they're exploring, how to put this together, how to make this more, basically their company more efficient because of the aforementioned conditions. So that it really did spread to suppliers as well. And then they tried to avoid strikes at all costs. So their approach was to ensure that the customer never regrets buying a Toyota. And that the next car that they purchased would be a Toyota. And that the price would be reasonable. So how did they achieve this? Well, their motto was to build in quality. Obviously, design robustness, which only proven features were included on cars. So you know how you'll see cars released and they have all these new trendy little gadgets and features, but with this, anyway, at that time, whatever those trendy newer features were, they only put tested, proven features on their car. So, many Toyotas don't have a whole lot of bells and whistles, or at least at that time they didn't. But like, I guess what comes to my mind is a Corolla or something. Like, it doesn't, it's just pretty much got your basic features. But they were very adamant about that. Only things that have been tested and proven. Stop at every deficit. So the line would be stopped when a problem would occur, and that would be studied. How do they achieve variety? Of course, there was a lot of range to appeal to different lifestyles, so that when you bought your first Toyota and then you're in a different life stage, you would buy the next Toyota. The next Toyota would be a different car they made, but it would, you could still get another Toyota that would fit your lifestyle. This is done by the use of flexible plants in existing production lines. So they have plants that can make more than one type of car or truck or whatever it is. So their plants are flexible and can be converted. And then there's the reasonable price, which is a commitment to quality. Quality at a reasonable price. So what's the competitive advantage of the TPS system? Well, there's obviously, now we know that Toyota's had some struggles, and but is really, I know that some of the airbags had struggles, but so did the actual quality control at Toyota. There were some other recalls, and I can't remember exactly what it was. I get my recalls mixed up because I have a Honda, and I've had so many recalls on my Honda lately that I get confused as to which one it was. Let's see. Well, there is one, you know, there's some issues with the fire risk. But the big one, the engine stalls and faulty airbags, yeah. And the airbags were a Takata, I believe. I'm not sure if that was the right outsourced, but I know that the airbag was, I think the airbags are outsourced as well. And so that's the problem. But there's been several. So there's been a question as far as whether there's been some lapse in Toyota quality, but at the same time they have such an established reputation for quality that I mean I've had Toyotas. They're excellent cars. You know, they just last and they run and they're just, you know, amazing cars. That and so are Hondas. So, you know, you just, but there have been some recalls, but normally over, if you look at the long-term performance of Toyota, it's been, you know, they're known generally for being safe, and they last long. They're really high quality cars. So what they were doing at this time is trying to have a competitive advantage over other manufacturers with cost, quality, and safety. So, and you know, the quality thing overall, it's just more have been recently with the recalls, but there's been a lot of recalls. I mean, like I said, I have a Honda, and there was some recalls in my Honda. So, but this is what they are known for, and that was the point when they started the TPS system, is that they wanted to be known for these things, and they were definitely successful at that overall. They also were able to reduce their time from order to delivery, the lead time. And then obviously morale, that they wanted to reduce issues and increase creativity. So, you know, there's some, with lean management, there's autonomy given to the employees to make some decisions and changes to help make whatever they're making, you know, the product more, have less defects, higher quality. Energy efficiency, their point, we wanted to cut energy use during production or carrying out processes. So we're going to look at Jidoka and just-in-time conditions. So Jidoka is creating a visual environment where it is possible to get work right the first time. And then just-in-time is coordinating all work continuously without the need for accumulating inventory or requiring overcapacity. This is rather challenging. It's basically create on demand. Not storing inventory. Basically minimizing inventory as much as possible. Not basing it on forecasts. You need up-to-date information. You kind of need to know your demand, you know, constantly. It's very difficult, but this is one of the main tenets of this of lean management, lean production especially. So Jidoka conditions are geared toward individual training standards, and just-in-time conditions are geared towards encouraging teamwork and Kaizen opportunities, which we'll talk about later as far as what the Kaizen and everything. You probably already read about it in your text, though. So, we're talking about training standards, individual strategies for the employees to be able to get it right the first time and make as few errors as possible. And then you have which is really more of a team-based thing, and changing conditions, environmental conditions. So Jidoka has 4 basic elements: a clear definition of the work, a way to stop work and call for the needed assistance, mechanical strategies to examine whether work equipment is functioning properly, and analysis of stoppages. Now, I believe in your burn text, you're going to see that in action somewhat. Let's see. Some of the training aspects of it. So, and then we'll get in like I said, some of the things in the burn text we'll go through, and we'll kind of get an idea of what this looks like. And then just-in-time conditions, obviously you have to steady the rhythm of production, get a flow, and match with real customer demand, which is tack time, creating a more continuous flow work experience, continuous flow, and reducing batches. So that is also in the burn example. And what that is it's actually a German word, and it indicates, it actually technically indicates the beat of music, but it represents the rate of incoming demand that your organization has to satisfy. So what you do, it's like an equation. If you want to calculate the tack time, it's the time available divided by the daily customer demand. So that's what you have to that's how you work that out. And then of course, continuous flow, which is one piece flow. And that is basically, you have to keep everything going steady. And what you want to do, and I'll just go ahead and tell you before I move on. There's a traditional manufacturing example in the burn text on page 50. I would read that because that's kind of what you don't want to do, and kind of the way it works in real life. So you don't really necessarily want it to that's an example of the inventory waste, and this is what the continuous flow wants to remedy. We want to keep it going. We don't want to you don't want to build up all this inventory. You only want as much as you need. And in the text, it talks about getting the machines as close to each other as possible. Leave no room for inventory other than the standard amount of work and process that's required. So that's one piece, one machine. And basically, you have to focus on, like, for example, if one machine is broken, like you have a flow, and if one machine is broken, then you can't run the other machines. So the whole thing shuts down, and you have to focus on fixing that one machine that is broken. So it's the opposite of the traditional approach on that page 50. And it helps you uncover actually excess machine capacity. And, you know, it's going to be like it's very different from traditional, but also you have to fix with one piece flow. You have to immediately respond and develop a maintenance program to prevent breakdowns on this line. So it really helps you focus on the line and the machinery, and you don't. Once you start doing it this way, you have to really focus on maintenance. And this whole one piece, one time helps you observe bottlenecks in the system. So, you know, it seems like, but just consider the changes between that example and your text on page 50 when you read the traditional manufacturing example, and then going from that to one piece flow. It's very different, but it will uncover all the problems that you're having in the system. And it helps with quality improvement. You get a lot more quality out of this method. So, like I said, it's described step by step in your text. And you want to make sure that you understand these terms: takt time, continuous flow, and reducing batches, which is basically the whole thing of, you know, batches and excess inventory. And the whole key with, or think of it like this: the whole key with the traditional manufacturing example and the one piece flow we're talking about, or just continuous flow, is one key thing I want to talk about with that is that when you do it the traditional way, picture this: you are making large amounts of inventory that you can't sell now, because your demand is this, but if you're basing it on a forecast, and then the demand at the time is lower than what was forecast, then you're going to have a lot of extra inventory that you can't even sell now. But with lean manufacturing, you can create a line that's flexible, that has more than one purpose. It doesn't just make one product, so that you can make just what you need of product A now, and then you can switch that line and make something else that you can sell now, rather than making one item only on one line and then storing inventory that you can't even sell now. So that's then the key to this. Because what every line in lean, if there's a manufacturing line, they're mostly flexible and can be converted to make another product. That's the whole point of it, because earlier when we were talking about TPS, and they went, or Toyota, you went bankrupt, they only had so many lines, they couldn't add more, so they basically had to learn to convert them. So that's the key there between these different types of manufacturing styles. Takt time is a rhythm for any activity. Well, I already talked about what it actually meant. It's German. It's calculated by assuming that the law of the large numbers will even out spot outliers, and we can start with an average demand to calculate the rhythm of the customer demand against the production time available, which I did actually already say this, sorry about that. But that's how you calculate that. So all activities to make a product or deliver a service are organized so as to never break the flow of work. Level plan is the commitment to produce the same quantity every week for a week or two, and then forecast what is expected in the coming weeks. So that's like they take a few weeks and then they try to forecast it from that. Pool with Kanban. Kanban. I think it's Kanban. Oops, excuse me. Whoops. Okay, pool with Kanban. Sorry. Pool with Kanban. Kanban is a card system that materializes information on physical cards. There are withdrawal cards and production instruction cards. Whoops. Go back to that. What you want to do is go to this. This is a good example of how to build one. Go to that example on YouTube and take a look at that. Basically a scheduling system. It's one method to achieve just in time. It's basically it's also called Toyota nameplate system. But it is it's a tool. The goal is basically for this card system is to limit the buildup of excess inventory at any point in production. And it limits the number of items waiting at supply points and reduces inefficiencies. When a limit is exceeded, it basically points to an inefficiency that should be addressed. So it's a method for just-in-time, continuous flow. Individual development in Lean. So we talk about teamwork. We talk about methods overall. But when we get down to the individual in a Lean team, what we're looking for is standards and basically the knowledge of work. So, with just the individual, skills are learned just during the whole process. And people, gain a lot from just doing the daily activities in Lean. They learn skills that they didn't have before, especially in traditional structures. More autonomy, more creativity, more innovation. All of that becomes commonplace with with their employees. It becomes kind of entrenches itself into the teams. Each person becomes much more knowledgeable and much more a part of the success and advantage of the company. There's a lot of engagement and involvement. So these managers, they help people with the development, and they develop. Standards are not just procedures in Lean. They're not rules, but there are standards are knowledge of work, and that's manpower, machines, materials, and methods. So the manager is a consultant, takes a consulting kind of role, but they teach the components of the knowledge of work so everyone can learn to master the elements. But they do have the managers do have to keep the knowledge the knowledge of work up to date, and make sure that everyone knows what they're doing. Then the employees can make that, innovate, use their creativity, solve problems. Visual management. There's a lot of visualization in Lean. The Lean, over time, Lean tradition has created tricks that help visualize problems concretely. And there's some examples in your text about that. And they can be very simple type of visual cues versus more complex ones. But basically they help reveal problems as they occur. So one of the examples in your text is that standards need to be expressed visually, and that anyone can see whether they're within standard or not. So it's like white lines on a road to separate one side of the road from the other, to tell you where you can pass and where you can't. So there's, some people will use different methods for that. But, it could be lines drawn on a manufacturing floor to show people where to stack boxes, or, something visual that everyone can see and understand what it means. So that's part of visual management. Make it obvious to everyone what it is. And again, you could think of, limitless examples, but that's just one of them. Daily problem solving. Obviously, the visual management and standardized work help give structure to daily problem solving. And there's examples in your text on that, but this is kind of basically, a problem occurs, investigate the issues, what's their cause, solutions, and check. And then every day you do that. You do that every single day. And then Kaizen, which is basically problem solving to return a situation to standard or improve the standard. When we're talking about lean management and manufacturing, nothing's ever perfect, so it's always being done. It's continuous. It never stops. And so Kaizen is about doing that. Always improving, or returning to standard, but then obviously improving upon that at some point. So the steps of this process, Kaizen, is identify a performance improvement opportunity, study the current work method, investigate new ideas, produce new method and a way to test it, implement method and track results, evaluate the new method. So basically this is for anything. I mean, anything that you're doing, whether it's making a product on a manufacturing line or decreasing like my example, when I did my Six Sigma project, we took that out of it. I had a problem. I was getting paid too late, or our company was getting paid too late, almost to the point where the bill would go to collections. The invoice would, they'd send the invoice. We would send the invoice, and then they wouldn't pay us till we had to call and bug them. So then I had to say, what am I doing here in my work method? Well, I didn't really see what I was doing wrong at all, so I didn't find anything. I was calling, but by the time it got to me, it was late. So I had to go back to the whole process and look at the entire process from start to finish, from the time that the customer ordered their appliances from us. I had to go look at their contract. I had to look at the billing department and how they sent the bills, or the invoice, or the billing invoice, all of that. And then I had to say, well, at what point in this process could I make a change? Well, if I couldn't make a change, who could I ask to see who could make the change? So I had to go through all these ideas of look through the whole process, look at the things that slowed it down, and then make the changes there. And sometimes I didn't have responsibility for that, but I would ask them to make the changes, and they did. I tried one thing and it didn't help. I tried another thing, it didn't help. But I tried the third thing and it finally got help, which was basically the delivery of the invoice. It was snail mail. And either they weren't getting it, or the mail was mishandled, or someone in the mail room didn't get it to where it needed to be. Sometimes, whatever that was, we bypassed all that and we just sent it to them by email. This is a long time ago, so it wasn't as common to use email when I was doing this. And so that helped a lot. Also changed their payment terms. That helped too. So there were different things that we did. We tested these methods. Some did work at first. Some didn't work at first. But finally we found the mix of changes that did. We tracked our results. We evaluated the new method, and we decided that it was a successful our project was successful, and that customer was on good terms with us now. So that's just an example of a process using these steps. You could use this for anything. It doesn't matter. You can use it for anything. Any kind of process. That's the beauty of it. So after the kickoff meeting, okay, so let's go back to your burn text. So after the kickoff meeting, you have an all-employee meeting in your text, and explains the shift to Lean. And the main takeaways are Lean happens on a project-by-project basis. I just gave you an example of one project, but it's continuously done for all projects. Everything that you do. It's not just a cost-cutting approach. It is a method to boost value. Yeah, and that's what I was trying to get to. I like to use my example because it's a process example, not a manufacturing example, because you're going to be reading, you already are reading about that in your text. And I don't want to overload you with this class, I don't want to present it as something that just is for a manufacturing facility, because it's not. It's just, it was developed there, but it still translates to service-oriented type of businesses. So make sure that you're reading this text and the examples in them, especially the training part, because it's really difficult to get people to come on board with this. And so you're going to see pushback and people like, I don't understand why we're doing this. And, it's just a different mindset. But just remember that I read about all of the tack time, one-piece flow, standard work, pool. And every time when you're going through that whole thing, it reveals issues and opportunities you would have never have thought of before. And flow is the problems as they happen, and it forces you to fix problems as they occur in any process. So when you have to change from the traditional method to the batch to one-piece flow, it'll make a big difference in your quality. That's one takeaway from that. And read about standard worksheets too. Standard work, it gives you the baselines for improvement. And it tells everyone what they're supposed to be doing in a simple format. So just make sure to read that, chapter 4 in both books. And just to go, I just started with the standard worksheet. We talked about, so tack time, one-piece flow, standard worksheet, making sure I didn't forget anything. And the, let's see, what's this? This is shaku. Just kind of strange, right? And then there's shaku. And that is, let's see, what's the origin of that word? It's a way to operate a semi-automated manufacturing line. So I would, for more information about that, it means load. It's basically single piece manufacturing process, which is what we were just kind of talking about. I just wanted to put that term out there because it's something that they use. But it's the whole one piece flow concept. And then standard work. It's basically and again, standard work creates a work signal and time standard for every step in the process. And you know, while you're doing your, you know, you're on the floor, you're making things more efficient. You make changes. The changes stick. There's going to be anyone that needs to do the job needs to be able to do it and consistently. So there's going to be a standard work that's going to show you at each step how long it takes and what you do, step-by-step instructions. And then pull system. And you want to make sure you understand what the pull system is, which is basically the whole thing about pull is the opposite of what basically the current traditional type of system, a traditional work manufacturing system, pushes batches of things forward. So what we're doing in this situation is pull, which is pull the parts we need. We only pull what's needed, the amount needed in the time needed. So that's the whole thing. Pull is at the customer, the pull of the customer, with the demand of the customer. So we're not just pushing out batches. We're pulling. We want to take the demand and we want to create just enough. So that's all for this week. Let me know if you have any questions or concerns, and I'll be happy to assist you. Hopefully you're getting a little bit of a grasp on Lean and how it works as far as the manufacturing and obviously service other industries with the process example. But if you're having trouble understanding any of the concepts, just let me know. And like I said, your reading is critical in this class because I can talk about the definitions, but when you read through the process and examples, it really gives you a better idea of how it works. So make sure your reading is critical in this class. And make sure to look at the examples if I give you a website or refer you to a different source in these presentations because they really are, you know, they supplement what we're talking about and kind of show it in action. So you want to see it in action and understand, you know, how it's done. And there'll be more of these in the class. We'll even have, like I said, I think I said in the previous presentation, we have a simple simulation later in the course, which is pretty cool, I think. But anyway, any questions or concerns, let me know, and let's have a great week. Thanks for listening.